Hello everyone, welcome back to Explore Electronics. In this video, let us discuss AC voltage applied to inductor and capacitor. In the previous video also, I have discussed the AC voltage applied to inductor and capacitor circuit, and we have discussed current leading, lagging, voltage leading, lagging, leading and all. So how to remember when we apply the AC voltage, how inductor will behave? Whether current flowing through the inductor leads the voltage or lags with respect to the voltage, and also with respect to capacitor, we need to understand. There is an easy method to remember the inductor behavior and capacitor behavior with respect to voltage and currents are considered. Let us discuss that in this video. Here you can see AC voltage applied to a pure capacitor, one side. In the other side you can see AC voltage applied to a pure inductor. As we have already seen in the other video, this is what the waveform of voltage as well as current for a pure capacitor, and AC voltage when we apply it to a pure inductor, this is the voltage as well as current waves. Here you can observe, if we plot this to a vector diagram like this, the phasor diagram what we say, if we take x-axis as voltage, that is Vm, that is the voltage with respect to the capacitor is concerned. Similarly, current comes in y-axis like this. What it says? How to remember this? By looking at the waveform, you can see here at the origin, you can see here at the origin, this is an voltage graph, the blue line indicating a voltage wave, the purple line indicating a current wave. If we look at this origin, the voltage wave is starting its values increasing from this point. But the current, it is already started here. If you project it back, it is somewhere here, it is already started, right? Means we can say in the capacitor, when we are going to apply an AC voltage, current is already started, lately voltage is coming. Means in the capacitor we can say the current, what we call it as I here, this I leads. This is how we are going to write the leading and lagging. So if you look at the voltage, it is starting late. This is what the delay we can say. So this will be the phase difference of 90 degree. So we get x-axis is Vm. With respect to that, if we plot Im, it is exactly 90 degree. So we say this current is already started from the origin to increase. Voltage is lately starting from the origin and it is increasing. So current leads and voltage, that is, lags in capacitor. Similarly, coming to the pure inductor, again I am taking the voltage across the inductor in x-axis. If you look at the waveform, here in the origin you can see this purple line is starting. This purple line indicating the current flowing through the inductor. This blue line is indicating the voltage, V is equal to Vm sin omega t. This, if you project it back again, it is started here. From the origin, I am considering the increasing waves, increasing values. So if we consider this compared to Im curve or current I curve, this voltage curve is already started over here. Means voltage is already started. So we say voltage leads the current. So in other words, we say current lags. Current lags and voltage leads in inductor. In capacitor, current leads and voltage lags. So this is always a bit confusing in between these two, how to remember. So if you look at the phasor diagram, you will come to know if Vm is here and towards the negative, if we are plotting the current and this is Im and the phase difference is 90 like this, we say current is lagging behind the voltage. If current is like this and voltage is like this, we say current is leading, that's why it is positive. If the current is lagging, it would be somewhere here, downwards. So other than this method, we have an easy trick to remember the pure capacitor and pure inductor currents and voltages, that is with a keyword or a code word called civil, C-I-V-I-L. Here this first letter C represents the capacitor. You can remember like this. This is with respect to capacitor is concerned. First I will be having I, that is current, then I will be having V. Means in the capacitor, current is leading and voltage is lagging. So by looking at this only, we can come to know in the capacitor when we apply the AC, current leads and voltage lags. Similarly, here we will be having L. So it is with respect to the inductor is concerned. You can see here L represents inductor. Again come from here. First we will be having voltage and then we will be having current. Here voltage leading, current I lagging. This is how we can remember the lagging and leading voltage or currents in a capacitor and inductor. Here you are not supposed to confuse with inductor and capacitor currents. So here by taking C as a capacitor, we are going in this direction. So current leads and voltage lags. By considering inductor, again we need to go in this direction. First V comes, so V is leading, current I is lagging. This is how we can remember the leading and lagging parameters in capacitor and inductor. In the next video, let us see the RLC circuit and the analysis of that by applying an AC voltage. Thank you.